Hello everyone, my name is Zhen Yang. I'm a student from Tokyo Institute of Technology. The paper will be presented titled AI-BPO, Adaptive Incremental BLE Beacon Placement Optimization for Crowd Density Monitoring Applications. During the pandemic of COVID-19, it is essential to keep the social distance, and the government urges people to avoid overcrowded indoor environments. The University of Tokyo has released the crowd monitoring application on campus, which detects the user's location by the maximum RSSI from beacons. As we know, an optimal beacon placement is crucial to service quality. As for the related work of beacon placement optimization, some research used the simulation-based method, which optimized placement with simulated signal distribution and determine the placement in a batch process. However, simulating cannot reflect all the environmental factors. The other use sensor selection method, which selects the subsets of the beacons of initial largely distributed beacons, which is impossible to derive a suboptimal result. In order to optimize the beacon placements to enlarge the signal coverage with less labor cost, we propose a method named AI-BPO, consists of the process of estimating RSSI distribution, generating detection probability map, determining a new beacon placement, and iterating adaptive optimization. We propose predicting the probability of RSSI from the beacon at each location by the Gaussian process. Inspired by our previous work, we gather the size of beacons at each high acquisition value location via Bayesian optimization. As the result, we can obtain the closed result by reducing most of the data gathering. For each location, by the convolution of RSSI distribution and the detection probability given RSSI as of a logit function, we can derive the signal detection probability of the signal at each location. Finally, we can handle the problem as the coverage problem from the multiple beacons and calculate the probability of each location covered by the signal from at least one beacon. To find the optimal location to place, we quantified the determination criteria by the detection probability improvement here. As for the determination, we estimate the circular shape of the detection area and select location with the most improvements. We need to update the map after placing a new beacon because the actual beacon signal coverage is not in a circular shape. The updating process is the same with the previous approach by the data gathering via Bayesian optimization, because placing a new beacon only increased the acquisition value around it. We only have to gather the data nearby, which largely reduced the labor cost. To conclude, we propose the method of AI-BPO to enlarge the signal coverage, and we conducted experiments and showed the effectiveness and labor cost of the reducing, such as 80% of time reducing. That's all. Thank you for your attention.